Advanced Algebra Chapter 7, Lesson 7, continuing to look at inverse relations and inverse functions. Now you remember there's only one concept that we're dealing with, and we're just applying it to different situations. And the one concept is this, is that the inverse of a relation is determined by taking all of the x values, or the domain, and switching it with all of the range values, or the y values. So the x's become y's and the y's become x's. And then we've been looking at how that looks in different situations. You remember with a table, well, let me show you real quickly. With a table, we simply switch these x values with these y values, and that becomes the inverse relation. We also looked at how to do that algebraically, where we have an equation, and again, applying the same principle, the y becomes an x and the x becomes a y, and then we were able to solve for y to look at the algebraic inverse. In this video, we want to look at the graphical inverse. In other words, what happens graphically? But again, we're going to apply the same concept, that the x values become the y's and the y's become the x's. Now, when you graph x squared plus 3 and its inverse, y equals plus or minus x3, you get all this stuff, and then you find this stuff, and then it looks stupid because you don't know what's going on. When you graph this function x squared plus 3, that's the parabola that we've done before. And then if algebraically we switch the x with the y and then solve, we get y is equal to plus or minus the square root of x minus 3, which is this blue graph here. And what the inverse ends up being is a reflection of this function over the line y equals x. So this dotted line that I have here is the line y equals x. That's a line with an intercept of 0, a y-intercept of 0, and a slope of 1. And what you'll do in order to get this picture is if I take this point, let's have this here. If I take this point right here that's on this graph and I measure the distance from here to here, and then I put a point that's the exact same distance over here, that would be this point right here. These 2 points are the exact same distance. And then if I took another point, let's say this point, and I measured here, and then put this point the exact same distance over here, I would get this point. And then if I took this point and measured the distance to the line y equals x, and then this, I would get this point right here. And then if I took this point, which is a little bit more difficult, because it overlaps, but measured that distance and distance over here, I get this point. So if I keep taking these points in this original relation or function and reflect it or match a point over the line y equals x, this is where that comes from. So the graph of an inverse is the reflection of the relation over the line y equals x. Alright? So we're just measuring the distance from the line on one side and putting another point on the other side that's the exact same distance, and this is what I get. So the inverse is the graphically is the relation reflected over the line y equals x. Another way to find this is to simply take any point on the graph, find its coordinates, and switch the x with the y. So in other words, if I had this point right here, this is the coordinate 1, 4. Well, its corresponding point, or its inverse point, would be you switch the y and the x. So instead of 1, 4, you have 4, 1. So you go over 4 and up 1, and you have its corresponding point. If I found this point, negative 1, 4, that's the coordinate of this point, negative 1, 4, well, flip the x and the y, and I have the inverse point. So over 4, down 1 gives me that point. And you can continue to do that with all these points. So two things we learned from this slide right here, that the inverse is graphically, the inverse is the graph reflected over the line y equals x, or we simply take any coordinate point and switch the x and the y. Now, there's one other way that we can look at this, and one other way I want you to look at it. And we can make a quick sketch of the inverse by interchanging the axis. In other words, let me find my little graph here. Here we have a graph a coordinate plane. So I have the positive x-axis marked in green here, and I have the positive y-axis marked in red. Now, in an inverse, what happens? The x's become y and the y becomes x. So graphically, I need to make these positive x values, they're going to become the positive y. So I need to switch places. And the positive y's need to become the positive x's. So I have to switch places. So how do I do that? It's a two-step process. First, I can turn my axis this way, so now these x values that were positive x are now the positive y's. They're the one that goes up. The problem is these positive y became negative x when I turned it, so what I have to do is to flip that mentally like this, and now my positive x's have become the positive y's, and the positive y's have now become the positive x's. So if you can picture that mentally, let's do it again. Just think about the x becoming y and the y becoming x. By rotating this, the x becomes positive, but the y's are negative, so I need to flip this way or reflect it over the y-axis. Now, you could rotate it this way first, and now these are the positive x's, but now I would have to flip this way so that these become the positive y's. So we can make a quick sketch by remembering how to do that. So earlier this year we had these absolute value functions. What would its inverse look like? Well, this positive x needs to become positive y, so I'll turn that. Now these positive y's are now negative x's. They need to become positive x's, so I'll flip it this way. So this would be the inverse of the absolute value function. X becomes y, y becomes x. Okay? Let's look at the quadratic function. It's actually the one we just looked at. So again, this would be the quadratic that we looked at earlier this year. So I need to make the x become y, and I need to make the y become positive x, so that's the inverse. Another function that we haven't looked at, but we will look at here shortly, and that's the cubic function. Y equals x cubed looks like this. So the inverse, the x needs to become y, and the y needs to become x. So this is what the inverse function would look like for an x cubed. All right. So you can make a quick sketch of these by remembering to interchange the axes. The positive x's become the positive y's. The positive y's become the positive x's. So I have a few examples here. Let's kind of mentally see how this looks when we do this. Okay. So you may be asked to graph. Whoops, I'm going to do this. Graph the relation and its inverse. So this is the equation y equals 3 minus 7x. So this is a linear equation. So the y-intercept is 3 and the slope is negative 7. So if I graph it, this is what it would look like. Alright, so this is the original relation. To graph its inverse now, I simply make this positive x become the positive y. So I can turn this so the positive x becomes the positive y. But now the y values that were positive are negative x values. So I need to flip this over the y-axis. So I'm going to flip this over the y-axis. And so now I have the case where I've made the positive x, which was green, is now positive y, and the positive y, which was red, is now my positive x. And so this is what the inverse looks like. So as I look at this example, this is a quadratic, you remember, and it's shifted down 2, and it's been squeezed. So this is what this would look like. And again, to graph its inverse, I need to make this x-axis the y-axis. So I'm going to turn it this way. And then I need to make this negative y now, which has become negative x. I need to transform that or flip that in the y-axis. So now it is the positive x. So this is what the graph of the inverse would look like. So here's the line y equals negative x. So when I graph y equals negative x, I have a slope of negative 1. And again, to graph its inverse, I need to make the positive x become the positive y. And then I need to transform this by flipping it in the y-axis. So flip it in the y, and so the y is now the x is now the y, and there's my graph. So three things to remember. The graph of an inverse is a reflection of the original relation over the line y equals x. And we can take each coordinate on the original relation and simply switch the y and the x. Or we can take the graph and then turn it so that the positive x-axis becomes the positive y-axis and the positive y-axis becomes the positive x-axis, and we can do that by turning it 90 degrees and then flipping it over the y-axis, and we can get a very quick picture of a relation and its inverse.